Okay, now that we feel comfortable finding the domain of functions, let's now start to talk about how to find different operations on functions. And so example one, I just want to express in function notation what each of these expressions means. So when I have here in letter A, f plus g of x, that's how that's read, f plus g of x, really all that means is just take the value for f of x and add it to the value for g of x. And B, C, and D all work exactly the same. So here in letter B, this is going to be the value of f of x, and then subtract the value of g of x. For letter C, this is fg, or f times g, if you want to think about it like that. And so therefore, we're going to have f of x times g of x. And then letter D is really the only one that has any sort of nuance to it. F divided by g of x is equal to f of x divided by g of x. And what I want you to notice is that by doing this operation, we introduced a restriction on the domain, because now this function has a denominator, and I know that denominators, in this case g of x, cannot equal to 0. And so maybe I'll just write that down here just so that it's totally clear. This denominator, whenever I divide, I know it cannot equal to 0. And so we're going to introduce a restriction whenever we perform the operation of division. And then the important remark down at the bottom of the screen is that the domain of the new function, whether it's the sum or the difference or the product or the quotient, it consists of all numbers that belong to both the domain of f and the domain of g, which means, and I'm going to use an important word here, the domain restrictions on any function carry over to the new function. And so you're going to hear me say that a lot in this lesson, that any restrictions on any original functions carry over to new functions. And I'll be very specific about when that happens, but that will end up happening in this lesson. So we're going to have to know how to find domain, and we're going to have to know that in some cases that restriction on one of those functions carries over to the new function. All right, in example 2, we're given a function f of x is equal to x squared, another function g of x is equal to the square root of x plus 1, and we want to find all of the following formulas. So here we go. We're going to talk about, first of all, the domain restrictions on each of these functions, because those are going to carry over to the new functions. And so for f of x is equal to x squared, I noticed that doesn't have any domain restrictions because there is no square root, there is no denominator in f of x, and there is no logarithm. And so there are no domain restrictions here. So I'm just going to put that there are no domain restrictions. And so what that means is that the domain for f of x is negative infinity to infinity. Now for g of x is a square root function, which means its domain restrictions are going to be that x plus 1 has to be greater than or equal to 0, which means that x has to be greater than or equal to negative 1. And so therefore the domain of g of x is going to be negative 1 until infinity. So keep those in mind, because those restrictions are going to carry over to our new functions. All right, so here we go. Let's start with f plus g. And so I'm going to write this using our notation from example 1, f plus g of x, which we know from example 1 is just equal to f of x plus g of x. And what is f of x? F of x is equal to x squared, and so I'm just going to substitute that in for f of x. And g of x is the square root of x plus 1. And so there's my equation, my function for f plus g of x. And now I want to discuss its domain. And the domain of f plus g is going to have any restrictions from the original two functions carry over to the new function. So for f of x, there were no restrictions, so nothing's going to carry over to this piece right here. But for g of x, we had this restriction that x was greater than or equal to negative 1, and that restriction carries over to the new guy. And so that domain for f plus g of x is going to be the same as the domain for g of x, which is -1 to infinity. Okay, f minus g looks very similar, so f minus g of x, we know from example 1 that this is just equal to f of x minus g of x. And so this is going to end up being x squared minus the square root of x plus 1. And by the way, you don't have to do any simplifying to that. That should just be left alone the way that it is. And so this is going to be done for part 2. We could call this part 1 and part 2. And so now the domain, again, same story as part 1. The difference here is going to have the exact same domain. And so the domain is going to be -1 to infinity. Thirdly, we want to find f times g of x. And so we remember from example 1 that fg of x is just equal to f of x times g of x, which is going to equal to x squared multiplied by the square root of x plus 1. And so again, what is our domain going to be? Well, the domain is going to carry over restrictions from the original g of x. And so therefore the domain here is also going to be, just like the first two guys, -1 to infinity. Now, in number 4, we're going to do f divided by g of x. And so we know that from example 1, this is just going to equal to f of x divided by g of x, which is going to equal to x squared divided by the square root of x plus 1. And now when we do division, we're creating a new restriction because now there is a denominator. And so we're going to have that denominator not be equal to 0. So if we think first about the domain restrictions, I know that x has to be greater than or equal to -1. That carried over from the restriction up here on g of x. But the new restriction, so maybe I'll say here the new restriction, is that x plus 1, or really to be careful here, I'm going to say square root of x plus 1, cannot equal to 0 because it's in the denominator, and the denominator has a restriction that it cannot equal to 0. If you square both sides, you're going to get x plus 1 cannot equal to 0, which means that x cannot equal to -1. And so by putting that square root of x plus 1 in the denominator, the domain of this quotient loses -1. So we're still going to write -1 to infinity. It's just that we don't have -1 in the domain anymore because the x value -1 now makes the denominator equal to 0. And that's not good news, folks. We do not need that denominator to be equal to 0. And so therefore we have to exclude -1 from the domain on part 4, where we didn't have to do that on 1, 2, and 3. And then fifth and finally, we want to do g times g. So sort of a goofy looking thing here, but g times g of x, which we know is going to just be g of x times g of x. And so this is going to be the square root of x plus 1 multiplied by the square root of x plus 1. And I know that whenever I multiply radicals together that have the same radicands, essentially the radical just drops off. And so this is just going to equal to and simplify to x plus 1. Now, if you look at x plus 1, does that have any domain restrictions? Hopefully you said no. There are no radicals, there are no denominators, there is no logarithm on x plus 1. However, there is a restriction that carried over from the original functions. These g of x's had a restriction, again, back up here at the very beginning of the problem, that x had to be greater than or equal to -1. And so that restriction has to carry over to the new function, which means that my domain is going to be -1 included to infinity. Even though x plus 1 looks perfectly normal, like it wouldn't have any restrictions, the fact that it's made up of two functions that have restrictions means that those domain restrictions carry over to the new function.